So in this example, I'll show how to solve a linear inequality and represent the solution using interval notation. So first off, if I'm going to figure out when the left side of this equation is greater than the right side, I need to figure out when they're the same. Okay, as I talked about before, if we can find that critical value, then we're going to be able to look at the possible intervals where the left side is bigger than the right side. So let's go ahead and find our critical values. So let's go ahead and solve the equality. Clean that up. All right, and now I have my critical value of 1, but since the rest of my work is dependent on that, I'm going to go ahead and check that real quick using substitution. Okay, now that that looks good, let's go ahead and look at our possible intervals. I like to go ahead and plot out those possible intervals first. I think visually it makes a little more sense. So I'll plot my critical value, and then our possible intervals are going to be either to the left or right of that critical value. And since I used a greater than or equal to sign here, I'm going to use a bracket to represent that. So I could go to the left here, or I could go to the right. And let's go ahead and write out formally what those intervals are. So the first interval here is just going to travel from all the way to the left, so from negative infinity, using a parenthesis for that infinity sign, all the way until I hit 1, and 1 is included in the solution set. And then the second interval is going to start at 1 and travel all the way to positive infinity. So let's pick some values that are in our intervals there. So I'm going to pick 0 for the first interval here. So x equals 0 will be my test value. And I'm going to go ahead and just pick 2 for the second one here, x equals 2 as my test value. And then we're going to plug those back into the original equation, or I'm sorry, original inequality, and see which ones work. Well, it looks like that first interval works just fine, so that is going to be part of my solution set. And based off of what I know lines look like, I know that the second interval isn't going to work. However, I'm just going to verify it just to be cautious, make sure, because if both of them work, then I'll know I made a mistake somewhere. And I have that -5 is bigger than -4. Well, that doesn't make any sense. So clearly this interval doesn't work, which again makes sense based off the fact that this is a linear inequality. And of course I could take a look at the graph, and let's do that now so that we can get a good idea of what this looks like graphically and how we can check our solutions that way as well. Great. So now, looking at the graph, we can clearly see that we did find the correct critical value. These intersect when x is equal to 1. Okay, and that kind of slices up our graph into these two sections. And what we wanted to see was when that left side of the equation, okay, which is y1 here, right, was bigger than the right side, the blue part of the equation here. Well, if that's the case, again, we want to know when the y values are bigger, so we want to know which one's higher up. So we look for where the red line is above the blue line. And clearly, I can see that the red line is up higher here than the blue line, and that is to the left of the critical value. So when x is less than 1, or from negative infinity to 1. Okay, and if I look over on the other side of the equation, I don't get that relationship I want, because I can see here that the blue line is above the red line. So again, the better we understand graphs, the more confident we can be in our solution because we have multiple ways of attacking and understanding our problems.